the topic here, value of object-oriented design, or let's be more generic, we'll call it class-based programming of real-time control applications is the topic, and a subject of importance to state-of-the-art process control systems of the future. Let's step back just a bit in time, bridge from Eric's timeline of 1970s through 2010, 4 decades of evolution of control systems. And fundamentally, there's been a number of different ways to program computers over the last 40 years, okay? And some emerging technology, specifically object-oriented technology, in the last 10 years. Given the change in programming environments, we are faced in our industries right now with a large installed base, which is exceeding 20 years of age. And a lot of us here are faced with a real significant investment that we have to justify moving forward. And we need to fundamentally understand how we can do this in a cost-effective manner, still preserving the capabilities of the past, but moving forward with the future capabilities that are available in the more modern control systems. As we move forward, we want to achieve things like improved OEE metrics, asset capability, and important, as was mentioned today in the opening presentation about cloud computing, we need to open up the control systems with that vast amount of real-time information to the upper layers to do more real-time data management and decision-making. To do that, we need to take advantage of some of these new technologies. So what has been the barriers over the last 10 years to adopting techniques like class-based or object-oriented programming? For most of us, Dow Chemical included, it's a very high cost of conversion. When you're coming from legacy environment to a completely different technology, the learning curve and the cost it can be excessive. On top of that, we have a skills or base of engineers who are taught in old techniques. The actual effort and availability of people to program this environment is problematic, to say the least. As Eric mentioned, we also have high risk of change, especially in live facilities. And the design intent when you're moving from an existing facility to a new platform can be at risk while you're going through this change. So what is the clear value proposition for making the leap of faith or technological change as we go forward? This is an old slide. It was modified. Invert the curve. It's a parabola going upward with the optimization at the peak. Fundamentally, I'd like you to envision where we were, okay? On the left-hand side is the degree of innovation, the freedom of engineers, application engineers, to create sophisticated control strategies to improve the operational excellence of our facilities. On the right-hand side is discipline. And the discipline is being consistent time after time again, providing applications that have low cost of ownership from a maintenance perspective. In the programming environments, use 1131 environment, you have a high degree of innovation in the free-form structured text environment. Many of our legacy systems were programmed in that environment. In the mid-80s to late 90s, a number of control companies came out with canned functionality, function blocks, templates, what have you, that were readily accessible. So you have this dichotomy fundamentally on the left-hand side of what I call creative chaos, where the engineers want to do the best they can possibly do for you, but in that environment, the cost starts to skyrocket. On the right-hand side, you have what I call mindless bureaucracy. Just do what I tell you to do. Here's the spec, just go do it, okay? In that environment, you stifle the creativity and possibly the value of the application you're creating, but you have lower cost because it's out-of-the-box functionality from the vendors. I would propose to you that there is an optimum, not a minimum, an optimum, using class-based, object-oriented type techniques, which are readily available in the IT world, but not so well used in our particular world. to use that technique to come to an optimum value, which I called structured creativity, or a hybrid between creative chaos and structured creativity. That optimal value is in the form of reusable, and I emphasize this word, reusable content that can be used in one or multiple projects. Borrowed this slide from one of our standards organizations, primarily focused in the discrete industries. Some people may recognize it, but it applies across all industries, whether it be continuous, batch, hybrid, discrete businesses. I propose to you that this reinvestment that we're facing us should strongly consider in the state-of-the-art automation world of considering object-oriented programming is a vehicle for creating new content, new capability in the form of intellectual property that has tangible value, tangible asset value. Typically, that's not viewed that way by our financial advisors, but I would contend that the intellectual property created in this hierarchical structure has every bit as much value as the tangible asset, the pump, the valve, the tank that's in the field. And if evaluated properly in an economic evaluation, you can make the case that in investing up front in a reusable object-oriented design, you can actually make a cost savings case and a value contribution case based on content or containers as you go up the level of sophisticating from basic device control to the total physical plant. So as you saw in that model, the intellectual property can be containerized from device control up through a group of equipment modules, through units, unit operations, and ultimately through entire process cells in an entire plant. And as you add more knowledge within that application, you are gaining more and more intellectual property value. And what is that capability that is containerized? By taking an object-oriented approach or class-based approach, you can have a significant time and risk reduction in the actual commissioning of operations and improve the reliability right out of the blocks. Because as you create modules and build them up, they are tested, and that testing and capability is inherited by the higher level of object content as you build the control strategy.